Hi there, I'm Mr. Orr, and today we are talking about, in your geometry textbook, sections 8.4 and 8.5 on proving triangles similar. And while we're not doing proofs in these sections, there's a lot to them that I want to go over with you. Let's go back to earlier in the year when we did triangle congruence in chapter 3. We had 5 different ways of proving triangles congruent. You will probably recall these: SSS, SAS, AAS, ASA, and HL. So that was side, 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 angle, side, angle, side, angle, and hypotenuse leg. You will also probably recall that these were congruences. So in other words, to prove two triangles congruent using SSS, you had to have all 3 sides of one congruent to all 3 sides of another. Here you had to have 2 sides congruent and the included angle congruent. So all of this was congruence. Now we're going to do similarity, which is just a squiggle without the equal sign underneath. And you have 3 different ways of proving triangles similar. One of them looks a whole lot like SSS, because it is SSS, but it's not the same. Over here, we had to have congruence. Over here, we have to have proportionality. Meaning, if you have 2 triangles wherein all 3 sides are similar or proportional to 3 sides of another triangle, then you have similarity. So if you have a proportion of 1 to 2 and all 3 sides are in that same proportion, then you have similarity. Different from congruence. All right, the second one is, in fact, SAS looks a whole lot like this one, but it's not, because in similarity, we are saying 2 sides have to be proportional and the angle in the middle has to be congruent. Over here we said 2 sides have to be congruent and the angle in the middle has to be congruent. Proportionality versus congruence. Similarity versus congruence. All right, and the third one is not over here in congruence at all. It is AA, which stands for angle. If you have 2 triangles in which 2 angles are congruent to 2 angles of the other triangle, then you have similarity. And the reason, and that does not work for congruence, as we've discussed, and the reason that works here is because, let's say I have 2 triangles here, and this one is congruent to this one, and this one is congruent to this one. You have these 2 triangles are similar, proportional. Notice we didn't worry about the third angle, because the third angle's theorem tells you that if you have 2 triangles with 2 angles congruent to the other to 2 angles of another triangle, the third angles have to be congruent. So we don't worry about that. Now, these 2 sections are going to involve a number of problems in which you have to either prove that 2 triangles are similar, or you have to establish that they're similar in order to determine a missing variable. What I'm going to do at this point, rather than take this time to do actually, let's do one problem here that would probably be worthwhile. It was on page 494 of your textbook, and it was the mountain problem, and I will show you what that was. That problem was, you had a mountain, and this right triangle magically went down into the center of the mountain, and so this is a right angle here, and this is a right angle here, and this was 30 feet, and this down here was 50 feet, and you had 48 feet down here, and you were asked to find this value here. All right, so we're going to say 30 is to x as, now that's the side of the small triangle to the base of the small triangle. That's going to be proportional to the side of the big triangle, which is 80, over the base of the big triangle, which is 48. And that you're going to solve by cross-multiplying, which we don't have to do because we've already gone over that. But in fact, make sure you don't make a mistake here and use 30 is to x as 50 is to 48. That doesn't work. It's side of small triangle, it's hypotenuse actually, of small triangle to base of small triangle, equal to hypotenuse of big triangle over base of big triangle. That one's important. Those do come up from time to time. All right, and I think I'm going to move on here to do section 8.6, which does draw some of these other things in with it and also goes through some other theorems that you need to know. So I'll be back. Thank you.